All right, welcome to the IAC class. Our lesson will be over lesson 421, which is raceway and conductor systems. One thing that I do want you to make sure that you go in your code book and highlight these parts. Chapter 9, tables 1 through 12, table 31015 B16, table 31015 B2A, 31015 B3A, and also articles 11014C1A, 11014C1A3, 11014C1B. This deals with conductor temperature and limitations. First thing, open your code book to chapter 9, table. What we have here is the notes dealing with conduit and tubular conductors and cables, the fill of the conduits. To be able to properly size the correct conduit to go along with the conductors inside, you have to use these 10 notes that are in table 9. Table 1 talks about the number of the conductors, but there's 2 informational notes. Since the minimum standards is what the National Electrical Code is written on, the informational notes basically tells you that depending on the application, when sizing the correct conductors inside the conduit, you have to take in consideration the length of the run, the amount of bends into it. Since this is the minimum and based on the tables 1 through 12, you want to make sure that you may upsize it depending on the application it goes into it. Let's take note table 1 for instance. Table 1 deals with the percentage of the cross-sectional area for 1 conductor in a raceway, 2 conductors in a raceway, and over 2 conductors in a raceway. Raceway fill percentages. A conduit having a single conductor can be filled 53% of the conductor's cross-sectional area. A conduit containing exactly 2 conductors can be only filled 31% of the cross-sectional area. And a conduit containing 3 or more, we can fill the conduit 40%. If you'll go to table 4, you'll notice in each one of the tables, it is listed by the type of raceway system used in chapter 3. In here, we'll be dealing with EMT in this situation. You notice that the sizes, the trade sizes, 1/2 inch, 3/4, up to 4 inch, and over 2 wires, 40%. This is the dimensions inside the raceway that those conductors will fill, and so we have to make sure that the raceways, when you do the calculations, do not exceed these the fill of the conduit. There's a 60%, there's your 53% for 1, and your 2 wire for 31%. Using the notes in table, same size conductors, Annex C can be used to find the maximum number of conductors permitted in a particular raceway. The conductor maximum is based on all the conductors being the same size in chapter 9, note 1. Tables C1 through C12 are based on the 40% fill. So they're automatically figuring it's going to be more than 2 wires or more. So we're going to use the 40% conduit fill. That's what the tables are designed for. Annex C also lists the maximum number of fixture wire permitted in each type of conduit. So if you'll notice in C1, it goes through here. You'll always look and make sure that you know what type of conductor insulation is on the conduit. And also, make sure you're using the correct type of raceway system. In this case, we're dealing with EMT, but there's flexible, there's rigid, IMC, and so forth. In here, if you go to number 12 conductors, you'll see a 1/2 inch conduit. You can install 3 number 12s in a 1/2 inch EMT conduit of type RHHW and RHH. Now, this is different depending on if it's a THHN or THN conductor, and those are based on table 310-104, talks about the different types of insulation. So since this is a thicker type of insulation, you're not as able to put in many of the number 12 conductors in a raceway that you could if you were using a THHN. Using different size conductors, then you would use tables 4 and table 5 of chapter 9. Used when combination of different size conductors are installed in a single raceway, chapter 9, note 6. Here again, use the 40% column of table 4 when there are 3 or more conductors. Use table 5 and 5A for dimensions of the insulated conductors. including the equipment grounded conductor and bonded jumper, and when calculating the raceway fill. Table 4 shows the maximum percentage fill of tubing and conduits containing different numbers of styles. So in this case, what we'll do, once you find out the number of the conductors you're going to have there, if you have number 12, number 10, and number 14 conductors, always find the type of insulation. You'll go over to the approximate area in square inches. That's what we work off of, is approximate area in square inches, since the dimensions inside is square inches. So we would look and see that number 14, the approximate area of one conductor would take up 0.0097 inches of square space in that space. Number 12 would take up 0.133, and number 10 would take up 0.0211, and so forth for the different size. Here again, each one of them shows the different type of insulation for those and the approximate area in square inches, all the way up through size 1000. In the table, once you find out the amount of space, the approximate area in square inches, the conductors, then you will go back to table 4. Here again, we're looking to make sure it's EMT conduit. We would go to the 40% conduit fill, and we would see how much the total that came up to in those would fall under here. That would give us the size of conduit that we need. Let's look at an example. What size EMT is required to enclose 12 number 14s, 4 number 12, and 4 number 10 THW and copper conductors. So the first thing we'll do is go to table 5, which gives us the conductors, approximate area in square inch each one takes up. Number 14 takes up 0.0097 square inches for one conductor. Number 12 would be 0.133, and number 10 would be 0.021 square inches. So where we're getting at is right here. Under approximate area for 14, 12, and 10, we got the 0.0097, the 0.133, and the 0.366. So what we do is we take that 0.97 times the 12 number 14s, the 4 number 12s, and the 4 number 10s. That gives us approximate area of 0.25 square inches that those conductors take up in that space. Now we go to table 4, chapter 9, to find 0.254 square inches is required. So we go to the EMT, we go down 0.254. We see that between 0.213 and 346 that we would need at least 1 inch, because it can't be less. We would need to have it in a 1 inch conduit. So the 0.25 falls under the 0.34 square inches, and that would take 1 inch EMT conduit to be able to go inside of it. Alright, the nipple fill. A length of conduit measured 24 inch or less is considered a nipple. 31015 B2A exception number 3 tells us in chapter 9 note 4 that nipples, we can disregard any adjustment factor depending on the number of the conductors in the raceway. Nipples installed between boxes, cabinet simmer, and closing conduit unit can be filled 60% instead of the 40% conduit. If it's a 24 inch nipple, we can use the 60% conduit fill in the cross section area. Here again, that's chapter 9, that's note 4 of the note. So we could take this example that we have 9 number 14s, 9 number 12s, 9 number 10s, and 14 number 8s. We would take cross section area based on table 5 again, add all those together, multiply by the number of conductors, and it gives us approximate area of 0.9726 square inches. Here again, we'll go back to table 4, chapter 9. In this case, we can go to the 60% column. We go over 0.9 is above this, but below this, so we would have to use 1.5 inch conduit. Yeah. All right. Thank you for the presentation. Thank you.